Hello everyone, my name is Ankit and welcome to this presentation on Big Data System by Team Orange. So this was a class presentation for IT 641 with 4 months to cover everything, and we tried to cover as much as we can in these 4 months. They were rigorous 4 months, and I'll love to share what we did in this class. And if you want more details, we have 6 more videos explaining every 2 weeks as to what we did in this class. So these were the high level goal in this for this class: understanding Agile, practicing some SQL queries, understanding distributed database design, learn, understand and implement the project using fuzzy logic, Python, JSON, Qlikview and Hadoop. So to implement these goals, we were given an order execution system or OES database. We were given the data model for that database, which you can see on the left side of the screen. We were given some sample data for that OES and an example fuzzy extension for OES database. So these are some specific objectives from the project. We created a local OES, which was just an extension of OES database. We understood fuzzy and implemented fuzzy on our local OES. We created a master OES by merging the data model, local data model from each team. Then we designed and implemented it in distributed database system, in cloud if possible. We created reports using Qlikview, queried data into JSON using Python, and implemented the master data model in Hadoop data system. Let's talk about our team now. We had a team of 6 people. This is me, Ankit Goyal, and on the right side you can see my technology expertise. This is Milan. This is Neeraj Gupta. This is our project manager Pujit Koryala. This is Omo Shaleva. And finally, this is Nana. We all work together in an agile format. So the course was divided into 6 sprints. Each sprint was 2 weeks long and had 4 scrums in it. Every scrum took place in person. Usually the place and the time of the scrum was specified at the starting of each sprint. At the starting of each sprint, we also created a sprint planning document which helped us throughout that sprint. We assigned tasks on Trello board. We used Trello board, by the way, to keep track of all our tasks. On the background you can see this is the Trello board for this class. We created lesson learn, which was really important because as we move forward we learned a lot from our mistakes, and we created meeting minutes for every meeting that we did. We started off by creating an execution plan. To implement execution plan, we used PERT chart and Gantt chart. Let's look at our PERT chart now. The PERT chart consists of components, the actual start date and actual finish date. PERT chart and Gantt chart were updated at the starting of each sprint if need be. This is our Gantt chart, and as you can see, these were the starting and the ending of each phase or components in our project. So we took like these 5 main steps to reach our final goal and implement everything in this class. First, we expanded the database and created a local OES. Then we used fuzzy logic to implement a fuzzy in our local OES. Then we created a master database using by merging all the data from different teams, and then created a distributed database design in cloud. Then we used Qlikview, Python, JSON to query the data and create some visualization in it. Then we used Big Data Hadoop to move the data and implement everything in HDFS. Now let's start by talking about expanding OES. Expanding OES. We had 6 sub-steps for expanding OES. Our first step was to select the direction in which we want to expand the OES data model. Then we created local OES data model. Then we implemented 60 queries on OES database. Then we tried to implement most of those queries using Excel pivot. Then we implemented everything on SQL Server and created OES database in MySQL. Let's talk about expanding direction. So there were 4 directions that were given to the class by professor: sales, promotion, payment, inquiry, and vendor. Our team orange was given sales promotion, and the other 3 team were given the rest 3 expansion direction respectively. Now let's talk about our data model. This is our data model for promotion extension. Our data model consists mainly of 4 sections: campaign, delivery method, campaign region, and promotion. Let's see campaign now. Campaign is a series of ads using various marketing tools that shares the same message and ideas to promote something. For example, winter sale, New Year sale, Black Friday sale. This is our sample data for campaign table. As you can see, campaign is connected to promotion, campaign is connected to campaign delivery, and campaign region. We have 6 campaign regions in a campaign. So these are the 6 regions in which a campaign can be implemented. Next is delivery method, which can be TV ads, newspaper ads, flyers, etc. Now let's talk about promotion, which had the actual discount that can be implemented on a product. Promotion also have many to one relationship with both product and campaign table. So now that we have talked about our data model, next was implementing 60 queries that was given to us by professors. So this is some sample queries, and these were some sample implementation of those queries. After implementing those 60 queries, we decided to reduce the number of queries by using function overloading and dynamic SQL features. And this is our package which have 3 functions, and we were able to implement most of the queries using these 3 functions. Let's take a look at one of those functions. As you can see, we have parameterized table name and column name to make the function more generic. So, and below you can see an example implementation of this function. I can change the name of the table, I can change the function from average to min max, and the greater than sign to less than sign or equals to sign. That would change the query accordingly. Next we work on pivot and create visualization sheets and reports to query using Excel pivot. Connected our Excel pivot to our Oracle database, and this is our sheet for employee, which can be filtered using cities. As you can see here, if I click all these are the list of cities. If I select some city, I can filter it accordingly. This is my data for each customer, each employee, my subtotal, sum of quantities, count of orders. You can see the final number of count for 14 number of employees. This is a slider using which I can change the date time. As I'm moving the slider, everything is changing dynamically. I can also change the slider and make it yearly. As you can see here, the data is changing as I'm moving the slider. The next sheet was the same implementation for customers. This is my list of customers, and I can filter them according to their city, state, and branch number. As you can see here, I'll just select a branch number and select OK, and this is the filter result for that particular branch number. Again, I have a slider for order date, which I can just move around to see a real-time change in my data. So basically, as you can see here, the columns are similar to as they were in employee table, and this is my sheet for products. which have brand, product description, product number, unit price, and quantity. If I expand a product, I can see this product was sold for these order numbers, and this is a unit price, and these were the quantities corresponding to that order number. And as you can see, if I'm clubbing them according to brand number, the data is changing accordingly. So now I'm getting a group by function data. Again, I have a similar slider for order date. Then we decided to create charts and reports. This is our sample report, a graph for products sold and the total summation. I can filter them according to particular categories. If I select OK here, you can see now I have certain products, and I can filter them according to branch number. I can filter them according to quantity. So Pivot have really easy drag and drop options. So right now I can just select anything from order line and I'll have everything I need right in my hand. And after implementing everything on Pivot, we decided to implement everything and transfer the data to SQL Server. Before actually converting OES database from Oracle to SQL Server, we first created a conversion table for all the Oracle built-in functions to their SQL Server counterparts. And for the function that we did not have SQL Server counterpart, we created user-defined functions to implement SQL Server. We did the same for data dictionary functions too. Then we did the actual data migration using SSIS tool. As you can see here, Oracle database is getting moved to SQL Server database, and this is in the screenshot. You can see that this is the table name, and the data is being moved to SQL Server. We did the same for MySQL, and below you can see here in the screenshot you can see the implementation and the code for SQL Server. So we've created the local OES. Now let's talk about fuzzy logic. This was again divided into 6 sub-steps: understanding fuzzy logic using the example provided in class, creating implementation plan, creating fuzzy data model, implementing fuzzy in Oracle, and implementing fuzzy in SQL Server, and then merging the extended data model for all 4 teams to create a master data model. To understand fuzzy logic, we created a fuzzy flowchart. Let's talk about this flowchart. We first made that all the calculations are present and correct, and then we created rules for triangle and trapezoid. Then we created fuzzy decision table. Then we created functions for triangle and trapezoids, and then we created triggers to move data from materialized view to tables. Then we created procedures to calculate the performance for that attributes according to triangle or trapezoid, and in the end we calculated the fuzzy decision for each campaign. After analyzing fuzzy and understanding fuzzy, we created an implementation plan. This was our objective for fuzzy implementation: analyze the performance of the campaign in our local OES system. To analyze the performance of campaign, we came up with 3 attributes: sales, profit, and number of products. For each attribute, you can see we also came up with how exactly are we going to calculate these attributes. These are the functions that we use to calculate sales. Within sales there was total, gross, returns, net profit, etc., and then profit, and then number of products. For each attribute, we had 5 categories: poor, below average, average, above average, and excellent. And then we came up with a list of fuzzy tables that we are going to use to implement fuzzy logic in our LOES. And finally we came up with a decision table which talks about how our 3 attributes result in the final decision, which evaluates the performance of a campaign. So for example, if the profit is above average, number of products sold is excellent, sales is excellent, then the campaign performed very good and we should extend its scope. Then we created a fuzzy data model. So this is a fuzzy data model, and we did exactly let me tell you how we implemented the tables. It all goes to the fuzzy data flow table chart that I showed you earlier. These are the basic tables and this is the calculation. Then we created a decision table, and then we created rules for tables and triangles and trapezoids. And then we created these are our attributes, and this is our materialized view, and this is our actual table for each materialized view. As you can see, if something happens in wetnet table, the data comes here and we evaluate the performance according to this. For this particular attribute, we do the same for each attribute, and using the performance weight table, final campaign decision is made. So that's how our fuzzy works. We used this idea and implemented it successfully on Oracle, and this is our final output for campaign decision. As you can see here, we can tell that some of our campaign did poorly, some of them need further analysis, or some of them did good. Then we converted our Oracle PL-SQL queries to SQL Server. So this is our database decision table in SQL Server. We compared this table with the one in PL-SQL, and they turned out to be the same. This is the count for SQL Server, and this is an example use case. In this use cases, as you can see here, it tells us how many campaign are in each decision. So we created many use cases for fuzzy, and this is just one example of those use cases. While converting, we did come up with a lot of analysis, like you cannot use insert before insert trigger in a SQL Server. Also, you cannot use for loop, percentage row type, colon new. But the good thing was debugging was easier in SQL Server compared to PL-SQL. So after implementing everything on SQL Server, we decided to create a master data model. Our team extended data model for sales and promotion, and the other 3 teams went in another direction. From each team, we had a data governance person who all formed a data governance team. They talked about how exactly we will be communicating and how exactly we'll be sharing the data. So this was the format which was used to share data among people. We merged the extension and came up with a master data model. As you can see here, the tables are color coded. This was our extension for promotion. This was blue team creating extension for vendors. This is purple team creating payment extension, and this is red team creating inquiry extension. After creating master data model, we implemented it, and using this query, you can see a count of number of rows in each table. So this was our fuzzy and master data model step. Now let's talk about distributed database design. Now this task was divided into 5 sub-steps. First is decision. Let's talk about it. We had a big decision as to should we implement everything on our local system or should we move towards cloud implementation, and we decided to implement everything on Azure cloud. Then we actually created the database, distributed database design, and this is how our design looks like. We have a local implementation of SQL Server which have fuzzy related tables in it. And then we have 3 implementation of databases: Oracle, SQL Server and MySQL, all 3 on Azure cloud. Everything is divided or based on horizontal fragmentation according to regions. So order line table is distributed using horizontal fragmentation based on regions. Promotion is distributed among these two region on Oracle and SQL Server, and quantity discount is shared between SQL Server and MySQL, and then there is hybrid implementation of product. In this table you can see more clearly that as you see here, for product you can these columns were the one that were vertically distributed between Oracle, SQL Server and MySQL. For quantity discount, as you can see, all the columns were distributed between SQL Server and MySQL. And for promotion, the data was split vertical. There was a vertical fragmentation between Oracle and SQL Server. Then let's look at our data model. This is our data model, which have our SQL Server implementation, local that have all the fuzzy related tables in them. Then MySQL implementation, which is on cloud, and then SQL Server implementation, which is again on cloud, and Oracle implementation, which is on cloud too. After creating data model, we decided to implement everything on Azure. This is a screenshot. As you can see here, FAOES, there is a SQL Server and Oracle Server on this Azure cloud. Some other team member created MySQL on their Azure cloud, and some other member installed everything and implemented SQL Server on their local system. We use the linked server to connect to all these clouds. This is a connection, Oracle connection string that we used. This is the SQL Server connection string that was used. And as you can see here, in our local system, local SQL Server, or using linked server, we were able to connect to Azure SQL Server, MySQL and Oracle. Then we used OpenQuery to query data. For vertical partition we used join. For horizontal partition we used union all. For hybrid partition we used join and union all. And this is an example OpenQuery. As you remember, product was had hybrid fragmentation, so we should use both. We're using both union all and join in them. This is a select statement, which is selecting tables from Azure SQL Server, from MySQL and from Oracle to come up with the product table. And this is an sample implementation. As you can see here, we got the data in a local system using OpenQuery. And again, we finally merged everything and saw this is our decision table, which turned out to be similar to our local implementation. This is what we did in our distributed database system. Our next task was to create reports using Qlikview and a data query using Python and JSON. Let's talk about it now. Let's talk about Qlikview first. This is a screenshot for our Qlikview. As you can see here, our Qlikview is connected to Azure Cloud, and these are our table names, and campaign for campaign table, these are our column names. So for chart property, if you go to dimension, we've selected campaign name and campaign number, and for expression we've selected sum of total profit. When I select OK, I get a report where I can see campaign number is color coded. These are our campaign names, and on y-axis I have sum of total profit for that particular campaign. We implemented other use cases using Qlikview. This is one of them where I can see my number of products sold for that particular year, that is 2003. And this is one more use cases where I can select a campaign name and the decision, and it gives me count for that particular decision and campaign. Let's talk about Python now. So in Python we imported these packages to implement distributed database design. This is my connection string for local SQL Server. This is my connection string for SQL Server, for Oracle Server, and Azure MySQL server. So this is my distributed database connection strings. After connecting to distributed database, these are our use cases for SQL, for fuzzy SQL, and after creating some use cases for fuzzy, we created some use cases for distributed database design, and our use case is basically checking the product yearly performance, and we are taking data from all three distributed servers. These are our data frames. So here we are executing those SQL queries and saving the data in data frames. df5 here is one data frame, and this is another data frame, and this is another data frame. And if I print df5, this is how it looks like, and this is coming from our local fuzzy SQL server. This is how the data looks like, and I can use matplotlib to plot this particular data. So this is my query in which I'm just plotting this data, and as you can see here, if I scroll down, this is the visual representation. If I print order joint, this is my query for distributed database system, which is giving us a yearly performance for our product. And if I use describe for number of products, it gives me min, max, and standard deviation for number of products. I can use scatter plot and see how my trend is going for one particular product. This is the trend for one particular product. Using Python, I can also predict the future performance of a particular product and do some analysis based on it. Next, we created JSON. So what we did was we imported a JSON package, implemented a use case, and converted the data into JSON. So this is how the JSON data. Now let's talk about big data Hadoop. So for big data Hadoop, we used Cloudera as our Hadoop ecosystem, and within Cloudera we used Apache Hive, Apache Pig, and Scoop. Hadoop use MapReduce functionality, in which input is mapped into different sections, and then we use reduce to reduce the mapping, and then do some analysis on it. So this is our flow chart for what we did in Hadoop. We first moved data from Oracle to Hive, then Hive to local file system, then local file system to HDFS, and then use Pig Latin to transform the data and do some queries on it. Let's talk about first one, Oracle to Hive. So this is our query, and we used Scoop to import data from Apache, from Azure server, which had Oracle installed in it. This is a username, password, and we imported data into Hive, created new table called dfaoes_region12_orders, and it runs MapReduce functions, and this is our output, and we were able to successfully move the table into Hive. After moving the data into Hive, we decided to move it from Hive to local file system. And if we exit and go to Cloudera, and we used this query to create a text file out of order table that was in Hive. So after doing this, we moved the local file system to HDFS. We moved the data to Hadoop environment by using this query, and after implementing this query, now you can see that orders.txt exists in Hadoop environment. Now we created Pig Latin script. So this is we are just loading the data and dumping the data out on the output console. In between, we can use some transformation for map and reduce functions, etc., but we decided not to do it in this time. This is the implementation of Big Data Hadoop, and it ran. We can now go to Pig environment, and in Grunt Shell we can execute the .pig file that we just created. So this is all we did in Big Data Hadoop. Thank you. So this is what we did in IT 641, and these are a lesson learned. We did learn a lot while we were moving forward. So this is our final analysis of different tools from this class. These 5 use cases were used over time to compare different tools, for example Qlikview and Python. For the use case 1 on the upper right corner of the screen, these are the results in different 5 tools: SQL, Oracle SQL, Pivot, Qlikview, Python, and Hadoop. So we wrote the query in SQL, and the data we received was in tabular fashion, and this data was used to compare results in different tools. We did the same for the other 4 queries, and we had the working data for those queries or use cases. After that, we implemented one query in Pivot. We were not able to implement the other 4 queries because it was too complex to implement in Pivot. So this is a pivot analysis. Pivot is really easy to use, plus you don't have to install anything. It's good for small queries. It's just drag and drop, and because it's just for basic drag and drop, it's really good for data analysis, just basic analysis. So later we implemented all the 5 use cases in our in Qlikview, and this is one query, and that's the other query. That's the 3rd use case, 4th use case, and the last and the 5th use case. After implementing all 5 queries in Qlikview, this is our analysis. Qlikview was really good for large data set. Pivot slows down if the data set is really large, but you can do analysis on large data set using Qlikview. You can write complex SQL queries. Qlikview is really good for data visualization. It has really beautiful dashboards with heat maps and whatnot. And Qlikview is good for heterogeneous data. So if your data is spread out and you have data in different Excel sheets or databases, Qlikview is a place where you can merge all the data and create visualization. This is the use case implementation in Python. As you can see, you can create some kind of visualization in Python, and this is the tabular result for use case 2, use case 3, use case 4, and use case 5. And this is our analysis for Python. Python is good for data wrangling. You can use sophisticated packages like pandas for analyzing structural data. You can do predictive modeling, you can do statistical analysis, and the good thing is it's really good for sharing and reproducibility, because you can put the code in Jupyter and share it with people. Then we implemented a use case in Big Data Hadoop, and this is our table for product number, order date, and quantity. So this is how we implemented this query. We imported data from our Azure cloud and inserted it into a Hive table, and we did that for all tables that were needed. And then we just wrote the SQL query in Hive using HQL, and that was the data. So our analysis from Hadoop is really good for big data set. And you can do a lot of data exploration in Hadoop. If your table have like millions of records, you can easily do some exploration in Hadoop. Lastly, we didn't have petabytes of data. Our data was not big enough for Hadoop. So unless you have data that is really big, Hadoop is not. You should go with Python or other analysis tools. Trello was used for project management. This is a Trello board for our team Orange. The first one talks about overview and announcements. So whatever were the announcements for the class, we just added it here. And then we have
team member skills and capacity. Then we have board for each sprint. This is a sprint requirement, so any attachment that was there for a particular sprint was added here. And then sprint planning, which mainly deals with the sprint planning document and other small tasks. And then we have a card for each scrum. This is scrum 1, attachments and task for that scrum. The task contains team member name, estimation, estimated time and actual time. Whenever the task was done, the person did the task was supposed to mark it completed. So this is how a Trello board looks like: sprint 1, sprint 2, sprint 3, sprint 4, sprint 5, 6 and further. We had one more Trello board for the class that had that is shared by each person in the class. This talks about all the requirements that were asked for each sprint, and then this is our Trello board. This is a card for team orange and team red, team blue and team purple respectively. To share and communicate documents, we used shared drive. As you can see here, this is where we uploaded all the documents. This is list of our final deliverables. We have all the documents that were needed in this class. And to communicate with each other, we used Facebook Messenger. This is our Facebook Messenger, where you can see that this is how our group communicated. So these were the things that were used by Team Orange. Thank you.
A special thanks to Dr. Cyrus Agawad. We learned a lot in this class, and it's all possible because of him. So thank you so much.